Alright, so this is for Algebra 1. This is your extended response example for Chapter 8, Part 2. So we're going to go through this problem. It's 3 parts. Again, I would suggest you try each one by yourself and then press play and see me do it for you. So it says the equation gives the time, t in seconds, when a golf ball is at 0 feet, a height of 0. Will the height of the ball reach 130? Explain. Alright. So again, let's just draw a picture real fast. I always like pictures. So here is my y-axis, here's my x-axis. X is time, and y is your height. Because of that 20, right, this quadratic equation means that somehow the golf ball started at a height of 20. And it was hit, it went up, and eventually it'll come back down. Okay, and this actually models that equation because this is when the height is 0, the height is 0 here. This models the equation. So the first question is, will the height ever reach 130 feet? So now instead of putting 0 there, we're going to put 130 in place of 0. So we're going to do 130 equals negative 16t squared plus 80t plus 20. And now, you need to do this problem using what's called the discriminant. And the discriminant is part of the quadratic formula. Now, before you can do that, you have to put this in the standard form. Remember, standard form is ax squared plus bx plus c. And you want that side to be equal 0 so that we can solve it. Alright, so I'm going to move the 130 to the right by subtracting it. I'm going to put it underneath the plus 20 because they can combine. This side becomes 0 equals negative 16t squared plus 80t minus 110. Alright. Now if you need to reverse this, you can. I'm not going to. So in this problem, my a is negative 16, my a. My b is 80. And my c is negative 110. And again, I'm going to use the discriminant to see if there's even a solution to this problem. If there's no solution, then it'll never reach that height. So let's use the discriminant. Remember, that is this b squared minus 4ac. That is going to be 80 squared minus 4 times a times c. And I'll punch in my calculator. Just use the calculator exactly as it says. 80 squared minus 4 times negative 16 times negative 110. And I get a discriminant value of negative 640. If your discriminant is a negative number, that means this equation has no real solutions. So will the height of the ball ever reach this height? No. Because the quadratic equation has no real solutions. So remember that discriminant can be used to determine whether you can reach height or not. Alright, so the next part says, will the golf ball reach a height of 116 feet? If so, when? So here we go, part 1. Plug in 116 in for your height, which is, again, 0 in this one. So I'm going to do in different color. 116 equals, and now this is, again, the right side is negative 16t squared plus 80t minus, sorry, not minus 110, plus 20. 116 equals negative 16t squared plus 80t plus 20. So the right side is the same from the original equation. The left side is now 116. And now we're going to solve this to see if there are any solutions using the discriminant. First thing I'll do is move the 116 to the left or to the right by subtracting it. 0 equals negative 16t squared plus 80t minus 96. Okay. And now I am going to find the discriminant. Again, A is negative 16, B is 80, and C is negative 96. Alright, let's see what we get this time. So, B squared minus 4AC, that's your discriminant, is 80 squared minus 4 times negative 16 times negative 96. And I'll put this in my calculator. and I get a value of 256. This is a positive number, which means there's going to be two real solutions, which means I can find when the ball will reach this height, and I'm going to do so. To do that, I'm going to solve this quadratic, and I can use various methods. Now, if you're good with your perfect squares, you know that 256 is a perfect square. So this is actually factorable. However, I am going to use the quadratic formula. Just simpler right now because I have the discriminant, and that negative 16 is in front of it. T squared, it's the a value. I don't want to deal with having to get rid of that. So I'm going to use the quadratic formula, which says x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that is the opposite. Oh, it should say t, not x, because we're finding t. X, or t, equals opposite of b is the opposite of 80, which is negative 80, plus or minus the square root of your discriminant, which you found is 256 all over 2a. A is negative 16. 2 times negative 16 is negative 32. And now this square root of 256 is a perfect square. It is exactly 16. So now I'm going to come up here, and I'm going to scroll me over, and I'm going to create two equations. T equals negative 80 plus 16 over negative 32, and t equals negative 80 minus 16 over negative 32. And I'm going to solve these two. So we have negative 64 over negative 32, which comes out to be 2. And we have negative 96 over negative 32, which comes out to be 3. So this golf ball actually reaches a height of 116 twice. At 2 seconds and 3 seconds. So I'm going to go over my picture. So if I come up to my picture here, that means that, say this is the height 116. That means that here, this would be 2 seconds, and here, that would be 3 seconds. And again, that is when the golf ball hits that height twice, once on the way up and once on the way down. Alright? Very good. Alright, cool. Now, part C says, let's just solve the given quadratic equation using the quadratic formula. So, now we're going to take the original one, where it has 0, and we're going to find when the golf ball hits the ground. So in this problem, I'll use, let me use this pink. In this problem, we're going to be finding this point, the 0, the x-intercept, when the ball touches the ground again. So I'm going to recopy the problem down here. So I think it was 0 equals negative 16t squared plus 80t plus 20. And it says use the quadratic formula. So I'm going to go ahead and use the quadratic formula. This is in my standard form. A is negative 16. B is 80, and C is 20. And the quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now the first thing I'll do to the side here is find the discriminant. So that is b squared minus 4ac. I need to work on my a's. Sorry, I'll redo that. b squared minus 4ac. So that is 80 squared minus 4 times a times c. And again, I'll just use my calculator. 80 squared minus 4 times negative 16 times 20. Ooh, that's a big number. I get 7680. And because that's so huge, I wouldn't even think about factoring it. The last one, 256, maybe you knew that was a perfect square. We could have done factoring. It might have been nice to do factoring, but we didn't. So now I'm going to use the quadratic formula, finish it up. So x equals opposite of b is 80. Opposite of 80 is negative 80 plus or minus the square root of 7680 all over 2 times negative 16 or negative 32. Now we're going to plug that square root in the calculator and get a decimal, square root of 7680. And we're going to round to 2 decimals. So I get in my calculator 87.6, and the 5 makes the 3 go up to a 4. And now I create my two equations down here. So the first one, and again this should be t I'm sorry, t and x, very similar thing. T equals negative 80 plus 87 plus 6.64 over negative 32. This is 7.64 over negative 32. 7.64 divided by negative 32 comes out to be negative 0.24. And you might say, that's strange for a t-value. Yes, it is. Let's try the second one. Hopefully get something better. Negative 80 minus 87.64 over negative 32. That is, give me 1 second. Calculator says negative 167.64 over negative 32. And when I divide those, now I get 5.24. And we keep the positive one, so what is the answer? 5.24 seconds. And again, if we go back to our graph and take a look, right, that would be this x value, 5.24. And you might say, well, why is the other one negative? Well, over here, if you were to keep this parabola going until it hits this imaginary x-axis, there, that's the second zero at negative 0.24. But again, we don't count that because we're not going negative. It's a word problem. So that's the answer. All right, so again, this is a great word problem. Hopefully you took a look at it, tried your best, and you'll study up for the summative assessment. All right, we'll see you then.